Hiya, and welcome to our first one of our recorded lessons. We're moving on to chemistry unit this time, so I decided it was a little bit easier for you to learn and do well on this topic with a little bit more teacher explanation. Really good unit. Now, because we're separate, we're going to have a little bit more to do than just the trilogy group. There's a few more lessons later in the unit where you get to learn a bit more complex reactions of the organic compounds. But today's just a bit of an overview of the simplest organic compounds, get you thinking about what they are and getting your head into chemistry again after doing some physics and biology. So today's lesson, you're going to need a calculator for your retrieval task, a pencil and a ruler to draw some diagrams, and a table later on. So we're going to start the lesson as always with a bit of retrieval. We did this a while ago when we were back in school, so reminding you now of how to calculate relative formula mass. So remember, we're going to use the top number and we need to add those numbers together. So the questions are at the bottom. I want you to pause the video now and calculate using this bit of the periodic table and your calculator, showing all your working, the relative formula mass of these numbers. When you're ready, just unpause and we'll go through the answers. Okay then, so go very quickly going through the answers. So HCl, hydrochloric acid, if we add the top numbers together, we have 1 add 35.5, giving 36.5, making sure that you're checking your answers and you know if you've made any mistakes. Moving on, sodium hydroxide, 23 for sodium, 16 for hydrogen, 1 for hydrogen and oxygen, giving 40. Next one is calcium carbonate, 40 for calcium, 12 for carbon, 3 lots of oxygen of 16 gives 100. Now look at my working. If you're getting any of these wrong, make sure that you can see where you've gone wrong. Next one, potassium hydroxide, 39 for potassium, 16 for oxygen, 1 for hydrogen, giving 56. Copper sulfate, copper is 63.5, 32 for sulfur, and we've got 4 oxygens there of 16. Remember that number 4 only counts for the oxygens, not the sulfur or anything else. So 159.5. And lastly, nice and easy, water, 2 hydrogens of 1 and oxygen of 16, making 18. Now remember, these are relative, so there are no units. You don't need to put grams on the end of it. It is all in comparison with each other. So hopefully you found that nice and easy. It's good to go back and retrieve the skills that we've already done. You will always get one of these on your exam, probably both of your chemistry exams, and you'll also have to use it in other calculations. So it's definitely good to just remind yourselves how to do this. And we're going to do some calculations retrieval in all of our lessons this week, building up to our reacting masses, which you know is our favourite. So moving on to today's lesson, our title is hydrocarbons. We're going to be looking over the next few lessons about different hydrocarbons. But first of all, what I want us to think about is what is a hydrocarbon. So this is just one example. I want you to think about and pause the video and look at that structure at the side over here that we are pointing to, and I want you to think, what is a hydrocarbon? So while you write it down, pause the video and we will go through it. Okay then, so there is our structure of a hydrocarbon, and this definition that we're about to look at now is actually a 2-mark AQA definition. They do ask for it in the exam, so it's a good way of getting those really simple, easy marks. Could at the end of the day be in a difference between a grade. So let's have a look. A hydrocarbon is a compound containing only hydrogen and carbon atoms. Now that word only, that's what you get your second mark for. If it asks you for the definition, just put in a compound made of hydrogen and carbon atoms will get you 1 mark. Put in the word only will get you that extra mark. So make sure you pause the video and write that down, put a bubble around it, make it really stand out because that is super important. So if we look at today and what we're actually going to focus on, now we know what hydrocarbons are, we're going to look today specifically at something called alkanes. We're going to look at the structure of them, we're going to look at the formulae of them, and we're going to look at the link between the number of carbon and hydrogen atoms in them. But basically today is about getting ourselves familiar with what alkanes are, what they look like, how we draw them, and why they are so important, because all of this feeds really nicely into the unit you've just done where you were thinking about problems with the environment to do with oil and burning fossil fuels, and that kind of links into this nicely. But all of the things we're going to talk about in the next few lessons come from crude oil that we dig out of the ground, the big black gloopy stuff, and it's how we make that useful and understanding why that crude oil is so important to us and how we make it that little bit more useful. So alkanes, we've got 2 examples there. There's many different alkanes. And as you can see, hydrocarbons are made of only carbon and hydrogen. So we've got the first 2 on the right of your screen there. So the top one with just 1 carbon atom in the middle surrounded by hydrogens, and then the one underneath it, we'll look at the names of them shortly, 2 carbon atoms in the middle with hydrogen surrounding them. So that is how alkanes are always structured. You've got a backbone of carbon through the middle and hydrogens all around. Now, each carbon atom will always make 4 bonds. So those little lines coming out of it that join the hydrogens on are covalent bonds. Carbon always makes 4 bonds and hydrogen will always make 1 bond. Now, that's to do with the number of electrons in their outer shell. Now, as I've already said, there's lots and lots of different alkanes, all changed by the number of carbon atoms, which then ultimately affect the number of hydrogen atoms. But you can continue adding carbon atoms to those chains for infinity, really, and they do become very long, and that affects the structure and the properties of them, and that's what we're going to be looking at tomorrow. So as you can see, when you are drawing these, the first thing you will need to do is draw the carbons through the middle. Make sure that each of the carbon atoms has 4 bonds, so 4 lines coming from it, and then fill up with the hydrogens after. So if we take this one at the bottom, we've got the carbons in the middle, and each carbon has 4 bonds coming out of it, taking into account this one as well in the middle that joins the carbon and the other carbon. Okay. Now, if we were in class right now, this is when we get the mods out. So if we look at this picture at the bottom, mods are used to show how these structures take up actual space because they're not 2-dimensional. So we have lots of little balls with holes in them, and you have your bonds. Each different ball, each colour, represents a different atom. So we would be using the black ones for carbon atoms and the white ones for hydrogen atoms. And you can then use little plastic bonds, as you can see here, to join them together. Now, if we look at this one is one of our alkanes. This is propane, and we're going to look at these in a minute. And this shows how they are arranged, because the bonds in carbon don't just go off. If we look at this in a flat 2-dimensional structure, they are 3-dimensional, so take up a 3-dimensional space. So it helps us to see what they would actually look like, and if we were in class, we would put them together like this. What we're going to do is look at what they would look like. You're going to draw some diagrams, and when we return to class, we will get them out and have a look. So if we look at the first hydrocarbon, the first alkane, it's called methane. Now, the first 4 have random names that we just need to remember. After you get past alkane number 4, they then start to form a bit of a pattern, and it links to maths really nicely and helps you to remember them. So what we got here in the middle that the arrow is pointing to, this is what we call our displayed formula. We've got chemical formula, molecular formula, structural formula. This is our displayed formula. And the reason it's called displayed is because it shows all the bonds available. So it's our first one. So we have 1 carbon atom. And as we know, 4 bonds, so it fills up with 4 hydrogens. So we can see here that the structure of it is thick, and the chemical formula is CH4. If we were to make it with the mods, this is exactly what it would look like. Now, it's called a tetrahedral arrangement. You don't need to know that right now. That will become important when you do A-level chemistry, because I know you love it so much. And this is how it actually takes up shape. So what I want you to do is I want you to write out, make some notes on this, write the name, write the formula, and draw this diagram out. You might need to pause the video to do that. So moving on to the next one. Now we have ethane. And as you can see, all that we're doing each time is we're adding another carbon atom on. And then that then means that the number of hydrogens changes. So if we look back at methane, it has 4. But here, because we've got one of the bonds in the middle, which is the carbon-carbon bond, that means that only 3 hydrogens per carbon atom can join to make sure that each carbon has these 4 bonds coming out of it. And then if we look down here, this is what it would look like if we were to make it, and this is the space that it takes up. So ethane, C2, so we've gone from C on its own to C2, and now we can see that we have 6 hydrogen atoms surrounding it. So I'd like you to draw that out, making sure that you've got all the bonds in place. Now the next one is propane. So as you can see, we've gone to 3 carbon atoms this time, and again we just methodically go through making sure that you're adding the correct number of bonds from it. So here we've got the 3 carbons bit that goes first, as I've already said, draw those first. So you've already used 2 of your bonds here to join them together. Then if you go, right, well this one's already got 1, 2, 3, 4, so you're going to put 3 hydrogens on there. We go to the other end, it's got 1, 2, 3, 4, so 3 hydrogens can go there. Now if we look in the middle, it's already got 1 bond to that carbon, 1 bond to this carbon, so we can only add 2 more hydrogens to that. And I'm not going to tell you the formula because I want you to work it out for yourselves. Okay, so that is propane. So we've had methane, ethane, propane, and number 4 is what we call butane. So you can see why it's number 4. You've got your 4 carbon atoms in the middle, and as you can see, we've filled up with the hydrogens around the outside, making sure that each of the carbon atoms has 4 bonds. If it doesn't have 4 bonds, you need to put another hydrogen in there to make sure that it does. Carbon will always make 4 bonds, no matter what it is bonding to. And then as you can see, the chain gets longer. If we're looking at the diagram of the molymods in the corner, the chain gets longer and starts to form a zigzag shape. Sometimes if you're looking up this on the internet, if you need any help with homework and things, you'll see structures that are just zigzags. Each zigzag represents what part of this. So you've got one, at the end of each one, you would have a carbon atom with its hydrogens attached to it. So this is your task now. I want you to draw this table, but I also want you to add another 6 rows underneath. So basically you need the space for 10 down here. So, but we're only going to use the first 4 now. Now you're welcome to go back through the video and have a look. Hopefully you've made some notes. So I want you to fill in the name, the number of carbon atoms, so put them in order, so this should go down, the number of hydrogen atoms, and from that I want you to write the formula. So CH4 was the first one that I gave you. So pause the video now and fill in that table, and then we'll go through the answers. Okay then, so just very quickly checking our answers. So the next one was ethane, 2 carbon atoms, 6 hydrogen atoms, and the structural formula was C2H6. The next one underneath was propane, so 3 carbon atoms, 8 hydrogen atoms, and C3H8 is your structural formula. And lastly, for the ones I want you to do right now, butane, 4 carbon atoms, 10 hydrogen atoms, C4H10. Now, like I said, these names, you do need to know them. In an exam, it can ask you it will show you one, it might even show you the molymod, it might show you the structural formula, it might show you the displayed formula, and you would have to name it. So these down here you need to remember. Now a nice little easy mnemonic: most elephants prefer bananas. Dead easy just to remember the way you go through it. So most elephants prefer bananas. Okay, so now we've constructed them, or we've seen what they would look like if we had constructed them, and we've deduced their formula. We're going to look at the next ones along, looking up to number 10, but you're going to also look at the link, because there is a link between the number of hydrogen atoms and the number of carbon atoms. So this is the table that we've just filled in. What I want you to do now is I want you to look at the link between this number and this number. And I want you to think of literally, like, kind of mathematically, what kind of like when you do nth terms, what are you doing to get from this number to this number every single time? So it doesn't matter if you're going down. I don't want you to think about that. I want you to think of how you get from the number of carbon atoms to the number of hydrogen atoms every single time. Because you might be asked to look at this and to say whether it is an alkane or not, and there's a general formula that will help you to identify alkanes, and when we move on to something called alkenes, you'll be able to compare them to it. And you must also, for the exam, know the overall formula, the general formula, which links the number of hydrogen and carbon atoms together. So pause the video, have a little look, and see if you can come up with that relationship. Right, so hopefully then you can see that to get from the number of carbon atoms to the number of hydrogen atoms, you double the number of carbon atoms and add 2. So you double 1, you get 2, add 2 is 4, double 2, add 2 is 6, double 3, add 2 is 8, double 4, add 2 is 10. So every time, no matter what, you are going to double this and add this on. So we could have 33 million carbon atoms, but the number of hydrogen atoms would always be double and add 2. So this is what we call then our general formula, where n can be any number. So to get the number of hydrogen atoms, you double n and you add 2. Now I want you to make a note of that. That is expected for your exams. When we do our practice questions, you will see that some of them just ask you to multiple choice pick it out. You might have to write it, but you will have to use it and understand it. So make a note of that. Now, moving on, your final task before you do a little practice question. You're going to, as I asked before, you had a table with 10 rows in it, so you're going to use the bottom 6 now. Carrying on and filling in exactly the same, only this time you're going to do it from your own knowledge using that general formula. Now the names, as I said, we're going to think about maths, are much easier, because now if we think of sides of shapes, you can use the start of those to help you to name these. So if we think of a 5-sided shape, it's a pentagon. Now if we take the pent bit, we put ane on the end, we get pentane. So it's kind of testing your maths knowledge as well. So think about your sided shapes, get the first bit like pent, put ane on the end, and that will give you the name of the next. And I want you to go up to 10. So your number of carbon atoms is still going to go up each time. Your number of hydrogen atoms, I want you to use the rule at the bottom, double and add 2, and then turn it into a little formula like that. So I'll pause the video and complete your table. Right, so let's see how you did. So we've already said the name of the next one is pentane. So carrying on going down, we should find it's got 5 carbon atoms, which means if we double it and add 2, we get 12. So the next one, C5H12. Going on is hexane, hex meaning 6. 6 carbon atoms, 6 times 2 is 12, add 2 is 14, so C6H14. Next one is hept. So we've got a heptagon, and now we've got heptane, so 7 carbon atoms, 16 hydrogens, C7H16. Now make sure that you are writing them like this. You can't have the numbers at the same size as the letters. If you wrote that in an exam, you would get them wrong. They are subscript, they are hanging down below the line. Octane, 8-sided octagon, is 8-sided shape. So we've got 8 carbon atoms for octane, 18 hydrogen atoms, C8H18. Nonane is the 9 carbon atoms, 20 hydrogen atoms, C9H20. And lastly, decane, giving 10 carbon atoms, 22 hydrogen atoms, C10H22. Now, we've not drawn any of the ones other than the first 4, but as long as you understand that you draw the carbon atoms first in a long chain and you fill up with the hydrogens around the outside, making sure that every carbon has 4 bonds, they're super, super easy. They just get very repetitive. You add in an extra carbon and 2 hydrogens every time in the middle. Okay, so that's it for today. What I want you to do now is open up the sheet of questions that is here as well. And I want you to pause the video, have a go at the questions, and then we'll go through the answers, and that will be it for this first lesson today. Okay then, so let's see how you did. So it's got a nice diagram there of the displayed formula of butane. Use the correct answer from the box to complete each sentence. Butane is a compound, okay? It's not a mixture. They are chemically bonded together in a covalent compound. So it's definitely not a mixture. Butane contains atoms of carbon and hydrogen. Each line between the bond in the atoms in butane represents a chemical bond. And the correct formula, very, very small, is the bottom one, C4H10. Hopefully you could make that out. Now, that's it for today. If you've got any questions, email me as always. I'll put it in the comments box. Feel free to give me some feedback and enjoy the next lesson, which is going to learn a little bit about fractional distillation and how we get all these out of crude oil.